Alright, testing 1, 2, 3, testing 1, 2, 3. We have moving bars, that's good. That means we are live. How you doing? Good to see you, good to see you. Just give me 1 second. A couple of things are doing on the backside here. Let's leave that open there. Alright, we got our planetarium up, and we got our other software up. I think we're ready to go, so let's go ahead and swap out of this. No, the stream's not over yet. Oh my god. There we go. That is also the wrong screen. There we go. Greetings, greetings, travelers. It's been a while. We're back. My name is Mike, and thank you for joining us here on Earthshine Education. This is our live planetarium show. This is Monday, the 15th of February. I hope you and yours are doing well. Now, before we actually start the show, get used to seeing a mouse moving around and kind of the way this looks a little bit. But before we usually start the show, we always start off with Astronomy Picture of the day. So let's jump to that real fast. That is not it. There it is. Hey, buddy. So, we usually use Astronomy Picture of the Day just to kind of start out our shows. This is an archive that you yourself can find. All you gotta do is go on to your favorite search browser, browser searcher, and type in Astronomy Picture of the Day. It's that simple. I believe there used to be an app for phones where it would swap your background to the picture of the day. The picture of the day, but I'm no longer sure if that is still a thing. Just to kind of show you what it looks like. It's normally a nice picture of something astronomical. In this case, this is the Rosette Nebula. And hey, how you doing? Sirius, please stop that. You're never late to the party. This party comes and goes as needed. And we have a growly puppy. Unhappy puppy. Nonetheless, as always, Astronomy Picture of the Day. Usually there's a photo, there's always a description, and plenty of links for you to click around on. Today's APOD is actually in preparation of something later on this week. It's a NASA JPL video of what is called the 7 Minutes of Terror. And it's the terrifying 7 minutes of having zero contact with your lander. Now, whenever you send a lander to Mars, there's a period of time where it goes through the Martian atmosphere, and you lose contact with it. So it's all automated, so you preset various things, you know, to blow off pyrotechnics, to get the heat shield off, to get the parachute out, things like that. Well, that's what this video is all about. I'm not going to click it, because I'm probably going to be using something like it in another video, probably later this week anyway. But this is in preparation for the Mars Perseverance rover. I did put up a video last week, and actually there was a video this morning, I believe, as well, for something different. This morning it was a telescope video, and last week it was a video on visiting Mars, because there was a probe from China. There's a probe from... Actually, China's got a satellite and a lander. The lander hasn't gone down yet. There's also the Mars probe called Hope from the United Arab Emirates. And actually, I'll be talking about that in just a second. And then on the 18th, so in 3 days, we will have the Mars Perseverance rover, which will enter orbit and then descend onto the planet. We'll be actually live streaming that, watching the NASA live stream of the entire thing. That's going to be the middle of the day, so it'll be great. Everybody will be able to watch as long as you're not at work. I did mention the UAE probe known as HOPE. This is actually the first picture it's sent back, and it's actually kind of cool. It got the Tharsis region of Mars right in here. These 3 shield volcanoes, all in a line, and actually just off the edge. It's kind of hard to see, but right along the terminator here, you actually see what is called Olympus Mons. Mount Olympus, and we can get a good look at it if we switch over to our digital software here. Let's zoom in. So here's where Mars is in the orbit, at least in this simulation. Let's see if I can get this to spin around. And while we're doing that, I'll ask you, how are you doing? I see some people out there on multiple websites. Again, remember, we are streaming to Facebook and to Twitch and to YouTube all at the same time. So I see messages and like viewers on various spots. And, you know, feel free to say hi. Of course, I landed on Mars, or arrived at Mars at the wrong time. So let's get Mars to rotate a little bit faster here so we can try to recreate the image that we just saw. Again, Mars is the red planet named for the Roman god of war, Ares in Greek. There's Valles Marineris, Mariner Valley, huge crevice along the surface, which would stretch across the United States. There are the Tharsis Montes, there are the shield volcanoes we see in the picture, and as you can see here, there's Olympus Mons, Mount Olympus, 400 miles, about 800 kilometers, give or take, 850 kilometers in size. Let's zoom in a little bit, there we go. So that right there, this is a simulation of what Mars looks like, and as you can see from, there we go. From this picture, this is from the Mars HOPE orbiter, from the UAE HOPE orbiter, and it's the same area. So we got Mariner Valley right over here, and Tharsis Montes and Olympus Mons. So yeah, really cool to see this exact thing kind of tilted over. Science ongoing, and the Chinese lander, when that happens, we'll try to watch it too, but you know, time zones are a thing. And again, this coming Thursday, is it Thursday? It is Thursday. We will be watching the Mars Perseverance rover landing. If you've never seen a Mars landing, it's a little nerve-wracking. I assume it's super nerve-wracking if you actually work on the thing, but from an outside viewer point of view, it's kind of nerve-wracking, and you know, you just gotta hope for the best, and we'll be here to watch that in just a few days. Now, let's switch over to here. This is, of course, our planetarium software, which you yourself can download at your leisure. Stellarium.org is the name of the software. It's what you're looking for. This is looking outside right now from my point of view on my portion of the planet here in Rio Rancho, New Mexico. As you see, the sun is out, and well, you don't see anything in the sky, but the sun and actually the moon as well. We're going to go ahead and start moving things a little bit. Again, I apologize if the puppy is a little bit loud. I'm not sure what he wants. I think he wants to play, but we were just outside playing in what's left of the snow. It did snow here a little bit, and it's been snowing the last few days. We'll be talking about the puppy a little bit later because he is named after a star. And it's a star you will see tonight. We're going to kind of go over what you'll see during this particular week, the week of the 15th. Buddy, we're going to have early phases of the moon, so we'll talk about moon phases. There's only one planet visible at night, and it's the planet Mars. Convenient, since we'll be talking about Mars later in the week. A couple of really cool constellations that you can use to find your way around the sky. Turn around and look at the northern part of the sky. Talk about the Big Dipper, which is not a constellation. It is what is called an asterism. It's part of something much, much larger, which is a constellation called Ursa Major. We'll get to that in a little bit. Just to orient ourselves, to the left is the east, to the right is the west, in front of us down here is the south, which means behind us way up there is the north, and we can rotate our planetarium as needed. Of course, the sun will always rise in the east and set in the west, and as you can see, the sun is currently slowly making its way towards the western sky. Let's go ahead and let that set. There we go. All right, so here we are. This is the sky tonight with no light pollution. Now, light pollution is an artificial construct. It is actually a function of where you live and the amount of light in the sky. This is set for a pretty good clear sky. If you live in a much larger city, you might not see as much. You might see only the brightest stars and, of course, the bright planets, including Mars tonight. But we have it artificially set to a fairly good sky, as if we're outside of city limits and away from the city lights, so that we can get a good look at the sky. Now, again, the sun rises in the east, sets in the west, and as it goes down, the sky will change color from the blue that we see scattering during the day to kind of an orangey yellow. And of course, if there's clouds in the sky, that would look gorgeous as well. And then the stars come out. Now, not everything you see above you at night is going to be a star. Sometimes there are planets out. Right now, the planet Mars is the only planet that you can see without a telescope that is visible in the nighttime sky. Stars, of course, will twinkle. That is called scintillation in scientific terms. It's just light diffracting through our atmosphere. Planets don't twinkle. They're not making their own light. They're just reflecting back sunlight. Sometimes you'll see satellites flying through our planetarium. There's one right there going by. Looks like it's an artificial satellite. Yep, there it is. Yeah. So yeah, you'll actually see that in real life tonight. It says 1851, so that's the time you'll be looking to see the satellite flying by. Actually caught me a little off guard there, so I mentioned it anyway. Let's slow down time here. There we go. So here we are, looking at the sky tonight, facing south. And the real question is, where do we start? Well, the obvious answer is going to be the moon. The moon isn't always out for you to see. There are some times where the moon is in the sky at the same time as the sun, and we don't see it at all. And there are times where the moon is out just a little bit right after sunset. And there are times where the moon rises up at the same time the sun is setting, and the moon's out all night. And there are some times where you don't see the moon at all till 2 or 3 in the morning. Why? Let's start off with moon phases, shall we? To do that, we're going to switch over to, actually, a website. That's not it. There it is. Here we are, looking at the moon, the Earth, and actually the sun would be off to the left here. So this is a moon phase simulator. Rather than... oh my god, what is that? Rather than recreating this, I'm just going to use this. Someone already made this. So, to orient ourselves, here we are looking at the Earth from above. This is the North Pole of the Earth. Here's the North Pole of the Moon. And the sun is way off on the left part of our screen. Not visible. From our point of view here on the Earth, the phase is new. When the sun and the moon are in the sky at the same time, that is a new moon. These are the times you can get what is called a solar eclipse. You don't want to look at those. They're really cool to see, but you don't want to look at those without proper filters or proper protection for your eyes, because you can and will hurt your eyes. So don't do that. Now, as the moon orbits around the Earth, the angle between the sun and the moon changes. We'll stop here. So we've gone a little bit around... there we go. We got about 40, 45% 45 degrees, I should say, around our planet. And so you see the moon is actually starting to reflect back a different amount of sunlight. This is the first quarter moon. Waxing moon, I should say. Anytime the bright side's on the right side, that is a waxing moon. First quarter moon is when the moon is 1/4 of its way around our planet. There we go. And we'll keep going. When the moon rises at the same time the sun sets, that is a full moon. They are opposite of each other. They are at opposition, as it is called. And that's when you see the moon the entire evening. That's when the moon looks really, really bright. Each full moon has a name. Full moon will be next week, so when we do a show next week, we'll talk about the full moon. There we go, there's full moon. Now we start the opposite side. So when the bright side's on the right side, the moon is called a waxing moon. When the bright side is on the left side, the moon is called a waning moon, because now the phases are reversed. You go from waxing crescent to first quarter to waxing gibbous, full moon, and then you have a waning gibbous, which becomes a third quarter or last quarter moon. And then that becomes a waning crescent. So these are the waning phases of the moon. These are the moons, the times you see the moon later and later in the evening, to the point where you're seeing it at 2, 3 in the morning, 4 in the morning, right before the sun rises. And the cycle will begin again with a new moon. Now, that takes about 28.5, 29 days. That is called a month. There we go, 29 days. That's where the word month comes from. Has to do with the cycle of the moon. Now, of course, in antiquity, people didn't have all the full scientific knowledge we have today, and they looked at the sun and the moon as deities. The sun, of course, was either Helios or Apollo. The moon was Selene or Artemis. Luna. And they either had chariots or, some sort of disk that they rode across the sky, trying to explain why these things disappeared. During a new moon, again, you can get eclipses of the sun. That's where the sun gets covered up by the moon from our point of view. During a lunar eclipse, however, that's actually where the moon lines up with the Earth's shadow. You can notice that the Earth actually will cast a shadow. When that happens, you can actually look at lunar eclipses. I believe there's one later this year. We'll talk about it when we get to it. Let's get back to our planetarium software. So there's our first topic of the day. It's going to be the crescent moon, and so the moon's going to look something like this tonight. Just a little crescent. People like to call this a young moon because it's just starting out the cycle. The bright side on the right side. If you have a set of binoculars, there's a pretty good time to look at the moon's surface. If you have a telescope, it's even better, of course. Look right along this line here, what's called the terminator. And you'll see a lot of relief. You'll see a lot of the actual surface indentation caused by these darker spots. These are the craters on the moon. These really dark spots are called the seas of the moon, seas or mare, but they're not actually oceans of water. They were at one point oceans of lava. That lava, of course, has solidified into solid rock, the way the moon is today. And there's actually something deep sky nearby, but we'll talk about deep sky stuff in just a little bit. Let's back out a little bit here. So there we go. We have our moon in the sky. Easy target. Good thing to start out with. The moon, the sun, and all the planets happen to travel along a nice line in the sky. We call that the plane of the ecliptic. However, it is also known as something else. Excuse me. And that's why they make mute buttons. Yikes. So, the plane of the ecliptic. It's also called something else. We call it the zodiac. Now, the Zodiac is a group of 12 constellations in the sky. It's actually a total of 13, but we really only recognize 12 for this particular grouping, because it's 12 months out of the year, so you assign one to each month, each lunar cycle. Now, what is a constellation? Before we go any further, what is a constellation? Well, a constellation is a grouping of stars that's officially recognized. We can actually put up pictures. That's what people imagined the sky looked like with all these constellations. However, let's get rid of the pictures. You'll see they're just stick figures in the sky. They connect various stars. Some of them are, great heroes. Some of them are, fish or dragons or flying horses, lions. Now, some of these constellations go back to antiquity. For example, the constellation Orion supposedly also had something to do with some Babylonian constellations, and I believe it was actually called Gilgamesh at that point. Some have also called it Osiris, but we call it the constellation Orion, and we're going to look at Orion in depth here in just a second. Again, good to see new viewers popping up. Feel free to stop me at any point, post in any of the comment boxes. Remember, we're streaming to Facebook and Twitch and to YouTube all at the same time. Totally happy to stop and answer any questions, or you can just sit back and relax and listen. Try to make this as entertaining as possible and informative as possible, and also relaxing. This shouldn't be a stressful thing. Got to be nice and relaxed. So, we talked about, well, again, the Zodiac constellations, these 12 constellations that the sun, the moon, and the planets all appear to travel through. But why? Why are they on this flat plane? Well, for those of you that have seen our show before, you've probably seen me switch back and forth like this. I do apologize, it can be a little jarring, but we do have two different softwares that we use, and one of them is called Universe Sandbox, and Universe Sandbox is a really cool simulation of our solar system like this. Our sun is a star, all by itself, floating around in space, with a small family of what we call planets. Now, the word planet comes from ancient Greek. The Greeks called the stars Asteroids, and they called these objects that moved around Asteris Planetes, wandering stars. Now, the objects that they called wandering stars were the moon and the sun, which we know they're not, well, the sun is a star, the moon is not a star. And there were 5 other objects that they could see, because there are 5 planets you can see without a telescope: Mercury, Venus, Mars, Jupiter, and Saturn. And they could see them moving through the sky, and they all happen to be on a nice flattened out plane. You'll notice I've put the planetarium software kind of on the side here, and as we even zoom out even further, all the planets appear to be on a nice flattened out plane. This is the plane of the ecliptic. This is the Zodiac, as we call it. From above, you see the planets are in elliptical orbits. They're not concentric rings, but elliptical orbits. The first 4 planets are called the terrestrial planets, terra meaning Earth-like. Let's start out by zooming in on the sun. Oh god, that's really bright. And there's our star, the sun, a ball of hydrogen and helium and other trace particles, fusing hydrogen into helium, releasing energy, making all the sunlight that we talk about. Mercury, the innermost planet of our solar system, is sun-scorched. As you can see, it does rotate in an interesting way. There is no atmosphere around this planet, and so it's just getting baked all the time. If you're on one side, it's super, super hot on the surface. As soon as you hit the demarcation line here, the terminator, as soon as you cross from sunlight into not sunlight, it's freezing. Looks like a big asteroid, but in reality this is a planet. It's very elusive, it's hard to see from the Earth. It is the closest planet to the Sun. We haven't really visited all that much with any orbiters. And there is one called Mercury Messenger that has been floating around. That was floating around. There's the planet Venus, the next planet in our solar system. Some like to call it Earth's evil twin. It's about the size of our planet, a little bit smaller, but it does rotate in the opposite direction. The sun rises in the west and sets in the east on Venus. It also rotates really, really slowly, to the point where a single day on Venus is almost as long as its year. You do not see its surface because of its atmosphere. It's made of carbon dioxide. It traps in a huge amount of heat. And so the surface temperatures are, well, 700 to 800 degrees Fahrenheit. A little bit higher, actually. Not pleasant. The only landers that have actually gone to Venus, they melted within an hour or so. I believe they're the Soviet Venera orbiters. Let's go back to Earth real fast. We mentioned Earth a little while ago. Let's slow this down. As you can see, on the Earth, you do get light pollution, which actually is kind of pretty and kind of terrible at the same time. You don't see really civilization, so to speak, when you look at the Earth from above, until you get to nighttime. When you get to nighttime, you can actually see large cities glowing, which is interesting to see. Like, there's the Nile River in Egypt. There's Madrid, Spain. You can see Paris. You can see London. These are also places you don't want to be to see the sky, because there's not enough actual starlight getting through all the localized Earth light, so to speak. Let's zoom out of this. Let's go to Mars, which we did visit a little bit ago. Again, Mars is about half the size of the planet Earth, but interestingly enough, it is tilted over like our planet Earth, and it also has a very similar day. It's called a sol. It's 24 hours and 37 minutes long here on the Earth, and so if you were to live on Mars, the clocks would actually be a little bit off, to the point where after a week, you'd be 3 hours off from Earth time. There's Valles Marineris once again, and the Tharsis region on Mars, the volcanic region. They're all extinct now, of course. There will be a Mars landing, again, mentioned it a little while ago. We're going to be landing on Mars, hopefully, with the Mars Perseverance rover. Most of the rovers land along the equator, because that's where it's easiest to land. When you try to land in polar orbits, the math gets a lot harder, and likelihood of actually surviving go down even more. There's a good look at Valles Marineris, which stretch from San Francisco all the way to New York City, crossing the entire United States, and about 8 kilometers deep, 5 miles deep, at its deepest point. So those are the inner solar system planets. Then you have things like asteroids, like Vesta here. This is an asteroid. It's a small planetoid. This is actually an asteroid, believe it or not. They're not all round like this, but some of them are more potato-shaped. They are kind of debris, chunks left over from the formation of our solar system. And zoom out a little bit more. I'm losing my planet orbits for some reason. I do not know why. Let's get them back. Excuse me. Leaving the inner solar system, we will enter into the realm of the giants, the gas giant planets, or Jovian planets. Jovian because they are Jupiter-like. Here we go. Here's the planet Jupiter. It is rotating very fast. It's about 8.5 hours along its equator. Jupiter does have what is called the Great Red Spot. It is a huge hurricane-like storm, about 3.5 to 4 times the size of our entire planet. This is not the surface, but the upper atmosphere of the planet itself. You do see these very interesting bands, color bands, different directionals for those clouds, and there again is the Great Red Spot. There are 4 large moons around Jupiter called the Galilean Satellites, or the Galilean Moons, named for Galileo Galilei. We first observed them in the year 1610. You'll learn a little bit about him if you click on our video about telescopes, because Galileo was not the inventor of the telescope, but he did improve on an early telescope and made some early discoveries. Now, one of the things he did discover as well was rings around Saturn. For some reason, this simulation doesn't have rings around Saturn, which is really dumb. I don't know why. This is Saturn. minus the rings. Saturn does have rings. It does also have a large moon named Titan, second largest moon in the solar system. Titan does have an atmosphere. Not sure why they didn't put rings on Saturn. Now, all the gas giants do have rings, Jupiter included in that, but Saturn's rings are the only ones we can actually see from the Earth. Here's Uranus. Uranus is an enigma because it is tilted over. So if you look at the picture of the planet Earth, right, you've got the North Pole facing upwards and the South Pole facing downwards. Well, Uranus is on its side. The North Pole is here. It's laying on its equator, so to speak, and the South Pole's on the backside here. So half the year, half of its orbit around the sun, Uranus has its North Pole facing the sun. Half of the orbit, it's got the South Pole facing the sun. Very, very strange. And rounding out with Neptune, you'll see Neptune is named after the sea god Neptune, or Poseidon, and you'll see it's very, very blue in color, hence the name. Very strangely, it has a bunch of cloud activity, which it shouldn't. It's really far from the sun. But there's still cloud activity in the upper atmosphere, which hypothetically shouldn't be happening unless the planet is somehow creating heat from its own interior. Maybe it's shrinking. We're not really sure. Nonetheless, this is how our solar system is structured. And you'll see, again, most of these planets are going to be on a nice flat plane. Now, the ones that aren't are going to be these outermost planets, what we like to call the trans-Neptunian orbits. Trans-Neptunian objects out here, such as Pluto and Quaoar and Sedna. This is the realm of the comets, way out here in what's called the Kuiper Belt. And even further out, there's what's called the Oort cloud, which is not represented here, but there's a huge cloud of comets, frozen material, way out very far from the sun. This is the structure of our solar system. It's the reason why we see the planets, the sun and the moon, all traveling on a nice flattened out plane in the sky from our point of view. As we come back to our planetarium, there we go. Once again, good to see you. If you are new to the channel, please like and subscribe. If you're just here to see what's going on, we're doing a little planetarium show. Right now we're talking about planets you can see tonight, and unfortunately there's only one planet you can see without a telescope, and it's the planet Mars, and that's what we're going to talk about right now. Now, normally you want to use stars to find your way around. Never use the moon as a marker, except for on a single night, because this is where the moon is tonight. So maybe I could say, look for the something, you know, just north of the moon or south of the moon, whatever. But the moon, because it's so close to us, tomorrow night will be here. And the night after that will be here. And the night after that will be here. And the night after that will be here. So if I said, look at this object just north of the moon tonight, in 3 nights, the moon is now up here. So you're going to be looking up here. You're going to be missing it if it's really over here. So don't use the moon. The moon's not the best way to find your way around the sky. The moon's really beautiful to look at, by the way. But it's not a good marker because it does move very, very rapidly from our point of view. What you want to learn how to use are the stars, because from our point of view, the stars all remained fixed. Now, they are all moving at different speeds and in different directions, but they're so far away from us. They all appear to stay in these constellations, as we talked about earlier, and they all have these little, like, borders. Now, there's 88 official constellations in the sky, recognized by the Astronomical Union. However, there are smaller groupings, what we call asterisms. I mentioned that earlier. Things like the Big Dipper. That's an asterism. It's what you can use to kind of find your way around the sky. It's a pretty easy to find shape. The Belt of Orion, for example, could be considered an asterism. But it's part of something bigger. We're going to look at Orion and some other stars around it here in just a second. Let's get rid of these. So, easiest way to find your way around the winter sky is going to be with the constellation Orion. Orion is just a treasure trove of observational, just astronomy. You can look at it and find your way around the sky. So visual astronomy, you can look deep at Orion with telescopes and see star-forming regions. You can see the difference in stars, because stars, of course, are classified by their temperature, which is indicated by their colors. You're probably wondering what in the world I'm talking about. Well, technically, it's out of this world. Let's look at this. Let's find our way around. So here we are once again tonight. It's around 6:15 in our planetarium right now. The sun is gone. We are facing south. We saw the sun set to our right in the west. And we are looking for 3 stars in a line. Now these 3 stars in a line... Come on, there we go. We're going to make a nice line right here. I made it a little bit bigger so that it's easier to see. These 3 stars make up the Belt of Orion. Each star has a name. Their names don't really matter right now, but if you really want to know, it's Alnitak, Alnilam, and Mintaka. Doesn't matter. We're going to use them to find our way around. If you can find Orion's belt stars, you can find his knee star down here to the right. This is a star named Rigel. Rigel is a bluish-white colored star. And the reason I'm mentioning this is going to be, in a little while, we're going to load up our other software, and we're going to look at the stars based on their size. So remember some of these names, because I'm going to try to bring them up and put them all together and show you that our sun is really small compared to some of these stars that we're going to talk about. So here's Rigel, his knee star. Draw a line up through the belt from Rigel, and you will find his shoulder star. This is a star named Betelgeuse, or Betelgeuse. Most of us just call it Betelgeuse. Betelgeuse is a red giant star. Jumping ahead of things, when stars form, they have a certain temperature, and they live their life as what is called a main sequence star. When stars are very blue, they're considered to be very, very hot relative to our sun. They're much hotter than the sun. When stars are more red, they're considered relatively cold, colder than our sun. When stars get really old, some things happen on the inside of them. They change compositionally, and they begin to puff up, and they cool off. They become what is called a red giant star. Betelgeuse is an example of a red giant star. And we'll look a little bit later at how huge it is in just a little bit. If you can find Betelgeuse, we can now find 3 more stars, which make an asterism. 3 stars, asterism, 3 points, that's a triangle, isn't it? Well, yeah, it's called the Winter Triangle. This is something that you see throughout the winter months. It's been up since January, actually since December. It's only been getting higher and higher up, and now, as soon as the sun sets, it's easy to see the Winter Triangle. You start with Betelgeuse, which we have already found, and then we draw a line down this way. You'll find a nice bright star. The other way of doing it is to use the belt stars of Orion and just draw a line through them. Either way, you end up at the same exact star. This is a star named Sirius. That's my puppy's name. This is the dog star. This is the brightest star in Canis Major, the big hunting dog of Orion. It is seriously the brightest star in the nighttime sky. It will twinkle really rapidly when it's low to the horizon. It's just really, really bright, very beautiful to see. The third star of the triangle, we have Betelgeuse and then Sirius. Draw that line between Betelgeuse and Sirius, stop in the middle, and head to the left. This completes your triangle. That star is called Procyon. Procyon is the brightest star in Canis Minor. That is the little dog constellation. Literally, there's only 2 stars, so it's a dachshund. I probably should have named my dachshund Procyon, but I named him Sirius because, well, reasons. So there's 3 different constellations you have already found. We found Orion. We have found Canis Major, which is actually a little bit harder to see because most of these stars are really faint, but you can find the heart star of Sirius, and then Procyon. Now, interestingly enough, as I mentioned earlier, these are going to be ancient constellations that have been kind of modified over time. They are probably Babylonian or Assyrian, and then they became Egyptian, and then they became Greek and Roman. They've kind of gone through evolutions. Supposedly, I need to go and double check and re-up my Egyptian knowledge, but supposedly Orion was called Osiris, and the star that we call Sirius was related to Osiris's wife, Isis. So, kind of an interesting little look back at history. Let's get rid of those. Now, what else can we find? Well, we mentioned the Zodiac a little while ago. If you can find Orion, you can actually find a couple of Zodiac constellations. First, let's start with that knee star once again. Let's go to Rigel. Draw a line through Betelgeuse and keep going. You end up here, very close to two stars that are parallel to each other. These two stars are the heads of the Gemini Twins. Oh, goodness, what did I just do? I closed it. That's cute. That was not what I wanted. This is what happens when you do live shows. Trying to be sneaky and use key commands, and apparently the key command I clicked was the quit command. Not the draw a line command, but the quit command. That's a bit embarrassing. Play them off, Johnny. Alright, back to where we were before, shall we? Yes. So, we drew the line through Rigel, through Betelgeuse. We ended up at these two twin stars, Castor and Pollux. Those are the Gemini Twins, one of the Zodiac constellations. Drawing a line from Orion's belt, not towards Sirius, but in the opposite direction, gets you up here. Now, this is a really cool grouping of stars called the Pleiades. They are a V of stars. They are the face of Taurus, the bull. The bright red eye of the bull is called Aldebaran. It, too, is a red giant star. Just past Aldebaran, again, you're going to keep drawing that line that we drew a little while ago. There we go. Keep going. You're going to find a little grouping of stars. This little patch is called the Pleiades, or the Pleiades. Some even call it Subaru, or the Seven Sisters. This is a grouping of young, bright blue stars. You can easily see it with just your eyes. If you have a telescope or a small set of binoculars, you'll see them a little bit more up close. Stars are usually formed in little groups. Open star clusters like this, all the stars will kind of float away from each other over time. So there's actually a pretty young grouping of stars, a little cluster of stars. But I thought we were talking about planets. Well, we kind of now know our way around this part of the sky, right? We found Orion, we found the constellation Taurus the Bull, we found Sirius, we found Canis Major, we found Canis Minor. But what does this have to do with finding a planet? Well, Mars is just to the right of the Pleiades. Now that we know how to find them, we again draw that line through Orion's belt, through the Hyades, and to the Pleiades. You can make a triangle between Aldebaran and the Pleiades and Mars for the next few weeks. So Mars is sitting right here. You might actually be able to cheat and just draw a line straight through the belt to Mars, but it's always good to kind of pinpoint these other objects as you move along. So that's where the planet Mars is tonight, and again, in just a few evenings, we're going to be, actually, in the afternoon on the 18th, we're going to be watching for a Mars landing, a lander from the American NASA project. It's called Perseverance. We're hoping to get another lander on Mars so we can get a human's eye view, so to speak, on the planet. Let's actually rotate around a little bit. Yeah, let's look this direction. Let's find a couple more constellations. So, it's almost 7 o'clock now in our planetarium. And you're going to notice a grouping of stars that's pretty famous, pretty easy to find. It is not a constellation, but it is a group of stars that are really easy to find. And they are called the Big Dipper, collectively. The Big Dipper is made up of 3 stars making a tail, going this way, 1, 2, 3, and then 4 stars making the cup, 1, 2, 3, and 4. That is the Big Dipper. It is actually part of something much larger, something called Ursa Major, the Big Bear. But the Big Dipper is something that a lot of people love to see. A lot of people are able to find pretty easily. And if you're from Alaska, it's actually on your state flag. The Big Dipper serves as a really good pointer in the sky, because these last two stars that I've left highlighted, we call them the pointer stars. They will point you to Polaris. That's the next subject we're going to talk about, is how to find Polaris in the nighttime sky. Polaris is the pole star, the North Star, the lodestar. Now, to find it, all we got to do is find the Big Dipper, like we just did. Find these last two stars, the pointer stars here, and point to Polaris. It's a straight line. You can't really miss it. If you do think you've missed it, it's not very bright. It might be easy to miss if you don't know what you're looking for. There's another way to find Polaris, the pole star, and that is to find Queen Cassiopeia. She was a vain queen. She enraged the sea nymphs and goddesses, and they threw her up into the sky, tied her to her throne. So half the night she's right side up, half the night she's upside down, holding on for dear life. And you'll notice in the picture there, she was holding on to a mirror, proving her vanity. She is made up of a W, or a 3, or an M of stars. However you want to look at it, it just depends on where she is in the year. So right now she looks this way. She's made up of 2 triangles. Where's my little line drawing tool? There we go. There's one triangle that's equal-sided, and then there's the other triangle that's kind of obtuse, it's kind of squished out. Find your equal-sided triangle, draw a line right through the middle of it, and you end up here. The same exact star that we pointed to with the Big Dipper. That is Polaris, that is the pole star, that is the North Star. As the Earth rotates, it appears to point almost directly at this star. And so we see stars rising and setting all the way around the sky, except for up here. All these stars basically stay up all night long. We're going to get rid of the atmosphere so that when the sun rises, we'll still be able to see the sky. As you can see, Polaris pretty much sits in the same spot. Polaris is the tail star of Ursa Minor, the Little Bear, which, oddly enough, is just the Little Dipper. So the Big Dipper, not a constellation. It's an asterism. It's part of a bigger grouping of stars. But the Little Dipper is a constellation. Very confusing. I apologize. Now, the North Star has not always been Polaris. There was a time period where Polaris was just another star in the sky, and the Earth was actually pointing towards something else called Thuban. It's actually this star right over here. The Earth actually wobbles a little bit like a top, and it takes, 26,000 years or so for this change. It actually cycles over and points somewhere near here, and then eventually will rotate back around, looking towards Polaris. Pointing towards Polaris, I should say. Now, that's all stuff that you can go out and see without a telescope. The next thing we're going to talk about, unfortunately you will need a telescope. We've got to stay in this part of the sky. I'm going to reset the time to tonight. Again, around, we'll pick 8 o'clock this time. Since, oh God, what did it do? Well, that's 8 a.m. I don't want 8 a.m. I want 8 p.m. There we go. Now, let's add the atmosphere back in. We'll talk about some other things. If you can find Queen Cassiopeia, which we did a little while ago, we had that little triangle, double triangles here. You'll also notice really low on the horizon, a great square of stars, 4 bright points of light in a nice long square. Well, that is the Great Square of Pegasus, because when you think of a horse, you think of a square, right? Not really. Again, constellations are just made up shapes in the sky. We'll actually talk about other constellations that don't exist for us, so to speak, if you use Western astronomy. If you can find the Great Square of Pegasus, and you can find Cassiopeia, you can find the next thing we'll talk about, which is going to be called the Andromeda Galaxy. Andromeda is actually right in here. It's between the Pegasus constellation, and her mother is Queen Cassiopeia. Princess Andromeda is the chained maiden. She's tied up. Now, to find her, you just got to find this great square of Pegasus. And so we got our square here. We're going to go count 3. 1, 2, 3 stars. And then she looks kind of like an A. 1, 2, 3 stars. So these 2 stars right here connect to the 3rd star. That's what you want to do. That's how you find Andromeda, the constellation, and the galaxy. Use Cassiopeia to pinpoint it once again. We have that triangle shape of Cassiopeia. Go through the tip of the triangle and you'll see you end up in the exact same area. So we're pinpointing it using just the stars. This is what is called a galaxy. Now, our Milky Way is a galaxy. It's a collection of stars. I'm not sure why I can't click on this to zoom in, but there we go. It's a collection of stars, gas and dust. All the stars that we see at night are in our Milky Way. This right here is a completely different galaxy. This is called the Andromeda Galaxy. It is likely that our Milky Way resembles this galaxy in the sense that it is a spiral. It looks like a big whirlpool of stars orbiting around a central core. Now you see there's lots of weird colors in that picture because, well, there's lots of gas and dust floating around in space in these galaxies. Where does it all come from? Well, let's go back to our friend Orion. We're now looking south once again. Let's go back to Orion and look for his belt once again. The 3 stars of the belt, find the middle star and go straight below it. And you will notice there's a little fuzzball. Look at it through some binoculars, you might see a little fuzzball. If you look through a telescope, you might see something a little bit better, but it won't have color. This is a colorized photo of what is called the Orion Nebula, I should say. This is an area where stars are being formed. They're being born, so to speak. When stars get older, they puff up, they become red giants, and they explode. Some of them die quietly, some of them explode violently, and they leave behind clouds of gas and dust like this, and eventually new stars will form from the leftover material. Also in Orion, just below the left star of the belt, Alnitak, you'll see something very similar. You see a big dust cloud. You also see what is called the Horse's Head Nebula right down here. You also have a reflection nebula. Reflection nebulae are blue, and that is light diffracting off gas and dust in space. Emission nebulae are reddish in color, and that's actually light being emitted, so it's glowing heated gas, glowing like a neon bulb. Then you have this right here where it's kind of a combination where you've got some stuff glowing, you've got some stuff being blocked out by actual dusty material, colder material. Very, very cool to see. But that happens all around. From our point of view, at night, all we see are just a few thousand stars. And we see this little streak in the sky, what we call the Milky Way. You have to get away from the city lights to see it. The Milky Way is a galaxy. It is our galaxy. And it likely looks something like this. There we go. Our star, the sun, is just one star along the edge of this giant spiral galaxy. Now, I said giant spiral galaxy, it's giant to us, but believe it or not, the Andromeda Galaxy is even bigger than ours. Or so we think. At least right now. The lighter blue stars that we were looking at in the nighttime sky, the ones that we see during the winter, they are on the outer portion of the galaxy. You'll see lots of bright blue stars, open clusters along the edges. You'll notice that the stars along the interior of the galaxy seem to be orbiting around something. We believe there's a supermassive black hole, an area of space so dense, not even light can escape it. And all these things are orbiting around it, and all the arms are orbiting around it as well. If you look at it from the side, you'll see the Milky Way is going to be flattened out. Centripetal force will do that. But you do have some stars in clusters going through the galaxy itself. Now, our Milky Way is not alone. Our Milky Way has a couple of companion galaxies. If you're in the southern hemisphere, if you live in Australia or South Africa, New Zealand, somewhere just below the equator, you're going to see the Large and Small Magellanic Cloud. And that's actually a set of irregular galaxies, as they're called. They're kind of like debris fields left over from the Milky Way possibly eating another galaxy, a small galaxy. Let's bring up what we call the local groups. So our Milky Way, take a step back. Think about your address. You have a home address, right? You have your building number, maybe your apartment number, you have your street number. Then you usually have your city, your county, your state or prefecture, or whatever it is in your country, a zip code maybe. All of that exists on the Earth. You have your country code, then you have your planet. Your planet is one of the planets of the solar system. The solar system is one star in this, the Milky Way. The Milky Way is part of what is called the local group. This is the local group of galaxies. They are all kind of spread out. Some of them are small spherical galaxies. Some of them look like the Magellanic Clouds that I mentioned a little while ago, which are just kind of like just irregularly shaped clouds of stuff. There's the Large Magellanic Cloud. We're in 3D space. This is a little bit awkward. There's the Small Magellanic Cloud. Had to back out far enough so I could see it. There's the small one. They just reuse the same graphic, but that's okay. And there's the Milky Way. Now, the Milky Way is on a collision course with the Andromeda Galaxy, which we just talked about. There she is in the distance. The distance between our galaxy and the Andromeda Galaxy is 2.25 million light years. At the speed of light, it would take 2.25 million years to travel what we just did in 3 seconds. In that time frame, both galaxies will get much, much closer to each other. And they will collide. Now, not colliding like two cars collide, but gravity will do a very interesting dance, and it will look something like this, where the galaxies will approach each other. Andromeda, of course, being the bigger of the two, will have kind of control of what's going on, because gravity is related to how massive you are. And the two galaxies will slowly merge together. Something like this. Some stars will be thrown out into deep space, never to be part of a galaxy again, likely. Others may collide, yet others still will try to find equilibrium and find orbit around the central cores that are trying to merge together. Beautiful dance, destructive dance. Always incredible to see this simulation. I've seen many, many versions of this simulation. This is the one that this particular software has available. Some of them are a little more detailed, but still always really, really cool to see. Now, let's clear all of this out. We talked about stars a little while ago and how they're different sizes. Well, I want to show you how things really are. Our star, the Sun, is what's called a yellow dwarf star, which means it's actually really small. You see the sun sitting right there. But what happens if we change the sun to a different star altogether? For example, we talked about the star Betelgeuse during our show, right? Well, this is how big Betelgeuse is compared to the sun. Betelgeuse would take up all the space from our sun, almost out to the planet Jupiter. You see Jupiter's orbit just past us. That's not what I wanted, I just exploded the sun. I apologize, I exploded our entire solar system. Just wanted to kind of show you that some of these stars are huge, so let's actually go to an empty simulation. That's not what I wanted. Empty simulation, please. Thank you. Let's start adding some of these things in, shall we? Let's put the sun. There's our star, the sun. How cute it is. Let's back away from it, and let's put in some of the stars we talked about today. For example, let's put in Rigel. Rigel is the knee star of Orion. That's that blue star. Look at how big it is compared to the sun. That's a bit concerning. Again, much, much hotter than the sun, hence the bluish color. We mentioned Betelgeuse. Let's put Betelgeuse in here. Oh, look at that. So the sun is there. Rigel is here. Betelgeuse is there. We mentioned Sirius earlier. Let's add in Sirius. There we go. So that's interesting. Sirius is not much bigger than the sun, but Sirius is very, very hot and very blue. It's actually got a companion star called Sirius B. It's a little white dwarf star. It's the core of a star that is now dead. If you haven't noticed, our sun is beginning to move very, very rapidly. It is being pulled in to its nearest companion at this point, which is Rigel. So I must hurry before everything explodes violently. Wolf 359 is a small red star. If you're a Star Trek fan, you've heard of Wolf 359. Take a look at that. It's just a small red star. It just have lots of interesting flares and things going on. But it's actually a lot smaller than the sun. So we're just kind of putting things here to kind of show examples of different stars and different sizes. Obviously, these things are not where I'm placing them. Bad things are about to happen. Can I grab and move the sun? Can I delete the sun? Can I delete it? Yeah, I can delete it. Okay, I saved our simulation. Yay! Let's put in some more stars, shall we? Let's put in Antares. Antares is the heart of Scorpio, which is usually only seen in the summer months, or if you're up really, really late right now, if you're up around 2 or 3 in the morning, you might see Antares rising up in the southern sky. Southeastern sky. You'll see it is also, again, a red giant. It's going to be about the size of Betelgeuse. Spica, you see in the summer months. Vega, you see in the summer months. And so, again, you see here, we've got some small, bright blue stars, such as Spica and Vega. But then you look at Rigel and you realize that some blue stars can actually be really, really big, too. Sirius, again, really, really bright at night, but it's not all that big, physically. So what does that mean? It means we're actually closer to Sirius, because it means... a good way to think about it is looking at a car light, right? When you see a car in the distance, or you see a light in the distance on a road, it looks like a little speck. And as you get closer to it, it gets brighter to your point of view. It gets brighter to your eyes. kind of the same idea here. Some stars are intrinsically bright because they are very bright stars. Some of them are bright because we're really close to them. There we go. That's the way it looks when stars change over time. You notice a difference in colors. You notice a difference in sizes. Some stars, again, can die quietly when they become these red giants. They'll just kind of puff out the outer layers, and they just become this huge cloud, what's called a planetary nebula, and it'll make something that looks kind of like the Orion Nebula, just a big cloud. Other times, they can die extremely violently, and one way that can happen is by the star itself collapsing, or if there's a companion star, because some stars aren't by themselves. Some stars will actually have a companion nearby, and they'll actually collide with their companion, and it'll actually do something like this, where the star will explode violently. That is also called a supernova. When stars implode on themselves, that is a supernova. When they explode like this, that is also a supernova, and you'll notice they're very, very violent. They're very, very fractally. Speed things up here. I might get multiple explosions because I put a bunch of stars together. At this point, we're no longer playing, we're just playing God. We're experimenting for science. That's kind of a quick tutorial on the life cycle of stars. You'll notice we haven't really been doing a lot of live streams lately. We've been working really hard on completing some stuff. Trying to find out if we can get a slot on local TV on public access to, do shows live there. That may or may not happen, and that's okay. We're going to continue working on stuff here. We've also increased our script writing, and we're actually going to be working on some more things. We're finally launching our Astro 101 series. I actually got 2 scripts for that. I just got to finish recording them and getting them all edited out is the next process. So we got a lot going on. We do appreciate you stopping by and, listening to us talk about the sky. We try to do this at least once a week. We did take a couple weeks off again to try to get enough stuff made for this application, but at least every Monday we'll be doing this. And again, on Thursday we're going to have a special Thursday show. We usually do Monday, Wednesday, Friday. We're doing a special Thursday show this week for the Mars rover landing. Please join us for that. I believe it's going to be at noon Pacific, so actually about the same time we normally go live. So please look out for that. That is our show. If you have any questions, we can handle them offline, or you can send it to us over on our Facebook page or our Twitter page. All of those links are usually on our websites. Actually should be on our Twitch page and our YouTube page as well. So you can find us anywhere. We do multi-stream because we're trying to get to the largest number of people possible. Please take care of yourselves. Please take care of each other. May you have clear skies. See you next time. On Wednesday, we'll do another show. On Wednesday night, the moon will be much closer to Mars. We'll talk about some of these same, pointers to find our way around. The best way to remember these things is just repetition. Keep doing them till you get them in your head. You know your way around the sky just by looking at the stars. And then as we go into March and April, these constellations will all disappear from the sky and new ones will appear, and we'll go over those and how to find our way around the sky using those constellations in just a few weeks actually. So please keep tuning in. Please share the channel if you can, if you'd like. We would appreciate it. We'd love to get more people viewing, just because we like to teach people. And it's hard to teach people if no one's watching. So please share us around. We do appreciate your time. Safe journeys wherever you are. Take care. We'll see you next time.